to lesson 6. Alright, so now we are coming to the lesson 6 about the revision of our whole basic modular bootcamp. So guys, how do you feel? Is my voice okay now? Everybody, is it okay? Alright, when it is okay, shall we start? Alright, here we go. So now today we will just come to our lesson 6. So for lesson 6 is actually review on the previous topic that we had. Include the words problem, the fraction, the number theory, and also the geometric that we have this Tuesday. Alright, so if so, then let's just get started. Here we go. First thing first, let's just go to the words problem first. So for the words problem, we cover 4 very key topics, including the age, right? And then the chicken rabbit problem, the interval problems, and the queuing problems. Above these 4 topics, for today's lesson, we will just talk about the question that you did with a very low accuracy rate. All right, so for the first one, let's just go to the age problem first. All right, for the age problem, first thing first is on this one. This is actually in our daily challenge of age problem, which says Marco is 42 years older than Cyrus, and Cyrus is 13 years old. In how many years' time will Marco be twice as old as Cyrus? Guys, do you remember, for age problem, we always talk about 3 very important things. Do you remember what is it? Do you remember for age problem, we always talk about the first thing first is about the difference never changes. Marco is 42 years older than Cyrus. Then Marco will be forever 32 years older than Cyrus. Right? So difference never changes. And what about the second thing about age problem? Do you still remember what is it about? Yeah, that is actually about the sum of 2 people. So the sum of 2 people would increase by 2 each year. Just like you and Mew, right? Mew increased by 1 year, and at the same time, you will also increase by 1 year. Alright, so this is about the sum, the age sum. Also, we talk about the multiple relationship. It's about times. Just like in this question, twice as old as Cyrus. This year is twice. Would it be also twice next year? No way, right? So that's what we talk about age problem. The very important 3 keys. So for this question, we have the difference. Also, we have the times. What should we start from? Any idea? Should we start from A, the difference, or we should start from the times, the multiple relationship? You can just tell me in the chat box. Great, dear. Good. All right. Well done, dear. Of course, we should start from the times. Perfect. Because times keep changing year by year. Right? So that's when we should start from twice. So it's like after many years, so many years later, that Marco will be twice as old as Cyrus. That means Cyrus is the 1 unit and Marco will be twice as her age. Right? Then what can we use? After we use the times and the multiples, then what can we use then? We still have one last one. It's about the difference, right? The difference, 32 years old. So where should I label the 32? Well done, dear. Since the difference never changes, that means for the difference between Cyrus and Marcos many years later, it will still be 32. If so, then we can just direct find out 1 unit is actually equals to 32. Now the question is asking how many years later. So that means how many years later we need to find out that it is Cyrus 32 years old. You find out that 32 years old, that the Marco's age will be twice as Cyrus. And now he is 13. So you can just use 32 minus 13 to find out it is actually 9 years later. That's how we come to the answer 9. Okay, then again, let's just review on age problem. For age problem, we always talk about those 3 things. Difference never changes. Sum of the 2 people's age would go 2 each year. And also the times, that means the multiple relationship keep changing each year. This year twice, next year definitely not twice. So always we should start with the multiple relationship. Then if it is lucky enough we have the difference, that is never change, right? So this is about H problem. After H problem, we talk about chicken rabbit problem. For chicken rabbit problem, very funny thing is we use one very, very important method. What is that? Oh, I got one very important thing, all right? Because just now you showed me it is not 9, right? Finally, you got me. Yes, it is not 9. I only got one student find out. It's actually 19. Do a very important, very, very important calculation. Thank you, dear. Perfect. Good job. After we find out this 19, sorry, let's move on and go to the chicken rabbit problem. Do you still remember? For chicken rabbit problem, one very important method is a drawing method. Are you going to draw everything? No. Once the number is very big, we shouldn't use the drawing method. You are not allowed to draw every chicken and every rabbit. No way. So what method shall we use for chicken rabbit problem? No matter it's about chicken or rabbit or dinosaur or dragons, it's all right. We always use the assumption method. All right, don't forget. We always use assumption method. For assumption method, that means we just assume all of those are chicken or all of those are rabbit. Then find out the big difference about legs. Then you can just transfer some of the chicken into rabbits by adding up legs to see how many rabbits we need. Same for this question, which is also in our daily challenge and chicken rabbit problem. We only get 77% of you correct. So let's just take a look at this question. It says a notebook costs $3 and a box of color pencil costs $9. And she, that refers to the girl in the question, all right, has a total of 10 classmates and she plans to spend $48. So how many boxes of color pencil can she buy? One thing first, all right, step one, we should just assume that they are all notebooks, all right, with the smaller numbers, all right. So we can just assume that at first, all notebooks. If they're all notebooks, 10 classmates, so how much should she spend? Yeah, she should buy 10, $3, so she should spend $30. But then she plans to spend $48, which means for the big difference, she can spend how many more? Which is $48 minus $30. So she still can spend $18 more. These $18 more, can she spend all these 18 on one thing? Definitely not, right? Because now you already spent $3 on the notebooks already. You still can add more to go to a $9 box of color pencil. That's when you need to find out the small difference between the color pencil and the notebooks. So for the small difference, it's supposed to be $9 at most you can spend on one thing, and $3 which you already spent. There would be $6 more, right? That you can spend on one thing and make it into the $9 color pencil. So that means altogether 18, right, divided into $6 one color pencil, $6 one color pencil, $6 one color pencil. Then you can buy 3 color pencil, boxes of color pencil. That's how we do. So let's just review on how we do the chicken rabbit problem. For the chicken rabbit problems, always we use the assumption method. For the assumption method, that means we assume they are all one kind of thing. For example, we assume that they are all notebooks. Then you will just find out if we buy all the notebooks, we only need $30, right? So there would be more that we can still spend, which is like we still have $18 to spend. Then for the small difference, which means how many more dollars you can spend on one more thing, that is like $6 more you can spend. Then use division, you can find out you can buy 3 more. All right, so easy, right? This is so easy. All right. Yeah, thank you, dear. After that, let's just continue. For the words problem, we still have one very difficult one, and which we only got 40% correct. Oh no. This one is very difficult since you need to think about the two different situations. Alright, it's like the first row of the seats was fully occupied. Right? And Robin was sit at the 12th seat from the left in the first row. Rosalina was seated at the 16th seat from the right in the same row. So there were 10 children between Robin and Rosalina. How many seats were there in the first row? What makes this question difficult is, do you know who is at the left and who is at the right? Actually, we don't know, right? That makes this question very, very difficult. So let's just come to case 1 first. For case 1, that is starting with an easier one, all right? That is Robin is at the left. Then we can start to draw them. From the left, this is Robin, all right? From the left. From the right, that is Rosalina, all right? Then in between them, there are 10 children. So the first children all the way to the 10th children in between, there are 10 of those sitting there. Don't forget, is that what? Robin is the 12th. That means he was the 12th. So starting from the first one from the left all the way to him, there will be 12 of those sitting there, right? And Rosalina was the 16th from the right. So starting from the first one from the right all the way to Rosalina, she was 16th, right? So this part is 16. So for the first row, altogether, it would be 12 plus 10 plus 16. That equals to 38. So the first row can has altogether 38 people. But then again, this is the one case, right? This is only one case. What about case number 2? For case number 2 is, what if Rosalina is at the left? All right, so we would just go Rosaline at the left. If Rosaline is at the left, so this is Rosaline at the left, this is Robin at the right. In between, there are 10 students, all right, 10 people, 10 of those sitting in between. All right, then we are drawing a very crazy one, which is Robin is the 12th from the left, all right, change another color. He was the 12th. So that means from the first one all the way to Robin, there would be 12 of those sitting on the blue color bench. 12. Right. And what about Rosaline? Rosaline was the 16th from the right. So this is the first from the right all the way to Rosaline. And there are 16. So then again, can I just use 12 plus 16 to get to altogether how many people? Can I do so? No way. You will see some of those were sitting on the same bench, right? That's when you need to take out the overlap. How do we take out the overlap? That is like we find out that there are 12 from the left, and then there are 16 from the right to plus 16. And take out those who is sitting on both bench, including Rosaline, the 10 people in the middle, and then Robin, which would be 2 of the main character and 10 of those in between, then you'll find out the answer is 16. So for queuing problems, you always need to find out the main character first. So first thing first, draw the main character. If it didn't tell you that these two characters, who is at the front, who is at the back, then there would be 2 cases, just like this one. You have 2 cases to go. All right, so then draw the other characters and make them sitting on the bench to add them up. This is about the queuing problems. For words problem, not just about queuing problems, we also talk about the interval problems, of which we only got 47% correct for this extra bonus. Do you remember, guys? For interval problems, we always need to find out the what first. We always need to find out the numbers of interval first, right? And then it really depends on how we plant the trees. If we start with trees, end with trees, so tree is always one more. When we start with trees, end with intervals, so they will be the same. What if we start with intervals, end with intervals, so the interval would be more. Right? If it is a circular loop, that must be the same. All right, focus in the chat box. All right, focus. Okay, so here we go. Let's read this very crazy question. It says, start from the start to the end of a row. 50 pine trees have been planted every 3 meters apart. Okay, so if this is the first pine tree, after 3 meters, we will go to another pine tree. All right, the town council plans to plant willow trees in between each of the two Jensen pine trees at 1 meters apart. That means for this 3 meter, right? After 1 meter, that we will go to a willow tree. After 1 more meter, we will go to another willow tree. After 1 more meter, should we go to 1 more willow tree? Not possible, right? That's what it meant. 1 meter, that we will go to a willow tree. 1 meter, that we will go to a willow tree. And 1 meter, and we go to a willow tree. That's what it meant. Now the question is, how many willow tree they must plant? Oh, now guys, what we need to know is how many such 3 meters are there? When you have 50 pine trees, guys, focus, all right? When we have 50 pine trees, the numbers of interval between them must be 50 minus 1. Because 3 must be 1 more. You start with 3, end with 3. So 3 is 1 more than the intervals. So you take out that 1 to get 49 intervals. Each of the intervals, you will plant how many willow trees? I plant 2 willow trees. So it's supposed to be the number of willow. It will be 2 in an interval, 2 in an interval, 2 in an interval. So it's supposed to be 49 times 2, which is 98. That's how we go to the answer, 98 willow trees. Then again, for the interval problems, no matter it's about planting trees, putting lamp posts, or then putting the plots, we always need to find out how many interval first. Interval is always the most important thing since it is about interval problems. It's about interval problems. It's not about any other problems, all right? So that you just need to know about how many interval first. Right? After the words problem, we also talk about the fraction. So for fraction, there are several very difficult questions that some of you didn't get it correct. For example, this one. Only got 60% of you got it correct. It says find the next fraction in the sequence below. Do you still remember how? Do you still remember what's going on? No. Okay. Good to hear is no. Actually, for this kind of question, right, we can just take a look at the numbers, all right? From 1 over 3, 1 over 2, the fraction is getting bigger, right? 5 over 9, yeah, it's also larger than 1 over 2. 7 over 12, okay, actually it's still larger than 5 over 5. Okay, so you can see actually the fraction is going bigger and bigger and bigger. So how can we make them find the next one? It's actually very easy. Since you are comparing, right, you can just try to make them the same denominator first, which is like 1 over 3. Then make them the same denominator, which is like 6, right? That is like 2 over 6 and then 3 over 6. What's going on? And you find out that, Miu, now you can observe the pattern now. Yes, look at the denominator. Once you find out it is 6, then from 3 to 6, and then from 6 to 9, and then from 9 to 12. It makes sense. What happened to the denominator? It increased by 3. Oh, then you say, Miu, from from 12 to 5, they're not increasing by 3. It's not. Then it's okay. You try to make it the same denominator to go to 3 also, 3 more also. When you go 3 more, it's supposed to be 15, right? Okay, so when it is 15, can you find out the equivalent fraction to it? Times 3, which is 9. All right. Okay, so now that the numerator we find out, we're supposed to increase by 3 to go to what? 18. Then continue. What next? Then it's about the numerator. Look at the numerator. From 1 to 3, what happened? Increase by 2. And from 2 to 5, what happened? Also increased by 2. And then from 5 to 7, what happened? Increased by 2. So from 7 to 9, what happened? Also increased by 2. So then from 9 to the next number, what should we do? Increase by 2. Then you will get 11. So that's how we go to the answer, 11 over 18. So guys, when you see the sequence, the number sequence, it's very easy to find out if the denominator are not the same. You just try to make it possible. All right, you should try to make them the common denominator and then compare what's going on. Especially for this one, number sequence, you can just split them into 2 parts, the numerator and the denominator. All right. After that, let's just go to another one about fraction. And actually, this is related to what we are having this week. Yeah, especially some of my students who just have my lesson about fraction words problem. Is that what? Is that he has some amount of money at first, and he spent 2 out of 5 of his money on a music player and 1 out of 3 of it on a camera. All right. Then if he has 144 left, so how much did he left? For this one, do you still remember what to do? Guys, if you find out is the words problem, the fraction words problem, what should we do? We should always draw what? How do you remember what we should draw? Especially for those who just have my lesson. We always draw the model, right? But then the question is like, when we are drawing the model, how should we cut that? Can we cut that at 5 parts at the same time 3 parts? Can we? No way, right? So we should find out the common denominators. So for the common denominators here, what should it be? It should be 15 of those, right? So that's when we cut them into 15 equal parts. So for this one, let me just do it part by part. So it's like this is 1, and then 2, and then 3, and then 4, and then 5, and then 6. Yeah, draw the models to do, especially what we are having for this week. 7, yeah, and 8, 9, and 10. Let me finish that. 11, and 12, 15, 13, 14, and where can I put them? And 15. Finally. 15 equal parts of his money. Then now we need to show the music player. For the music player, it's supposed to be 2 over 5. But then 2 over 5, where we cut them into 15 equal parts, it's supposed to be how much of the 15? Yeah, we should times 3 to go to the equivalent fraction, which will show you 6 over 15. So 6 over 15, I give you another color. 6 over 15 is on the music player. So this part is 6 over 15 on the music player. And what about 1 over 3 on a camera, which is supposed to be what? The equivalent fraction. Yeah, what are they? Which is supposed to be times 5. So this part supposed to be times 5 also. That would go to 5 over 15. So that means for this part, 5 over 15 is on the what? It's on the camera. So he still have, as what is that, $144 left, which means 4 units is 144. Now, do you know about 1 unit now? Now, what that there? So this one unit is supposed to be 144 divided by 4 to give you 36. That means 1 unit is 36. And what about the whole thing? Which altogether, there's supposed to be 12 of those, right? So it's supposed to be 12 times 36 to go to your answer, which is, let's do it together, 36 times 12, and 6 times 2, 12. 3 times 2, 6 with the carryover 1, 7. And 6 times 1, that's 6. 3 times 1, that's 3. And then you add them up, you'll find out it is $433. That's how we do. For the fraction words problem, we can always draw the bar models to help you. So for the bar models, when you find out there is more than one fraction, you need to ask yourself, do you need a common denominator? This is what I just have in my lesson. When you have more than one fraction, always ask yourself, do we need common denominators? If we need, then you just make it happen. Like they are talking about the same thing. So we just make it like this. Then label the correct thing at the correct place. Then you can just find out for the rest, like say 4 unit, 144. So then for the 1 unit, it's 36. For altogether 12 unit, not 12, nobody finds it. It's that, that means nobody is listening. So guys, how comes it is 12? It is not 12. Altogether, how many units? It's supposed to be 15 units, right? So it's supposed to be 15 times 36. How comes nobody found out? That means you're not listening. It's supposed to be 15. Altogether, there are 15. So it's supposed to be 15, and you still allow me to get it wrong. It's supposed to be 5 times 6 that gives you 30, and then 1 times 6 with the carryover 3, 9. All right, and 3 times 5, that is 15. With the 1, 3 is 3. With the 1 is 45, which is 0. And then 4, and then 5. Finally, 540. All right. So for this one, dear, don't forget, right? Always use the bar models to find out. If you didn't say mu is wrong, then I will keep doing it wrong. Okay, so for this one, then again, we draw the bar models for the fraction words problem. Always ask yourself, do we need common denominators? If we need common denominators, then make it happen. If it is not, then you can just directly do like that. All right, thank you guys. After the fraction, we also talk about the number theory. For number theory, everybody get it correct on the, most of you are getting correct on the odd and even numbers. It is not very difficult for you. That's a very good one. But for factors and multiples, we have several questions that most of you did it wrong. Like 57% of this question. Find the sum of all the factors of 16. Actually, to find all the factors of 16, that's very easy one. Right? Just do remember, Mu said, how do we find out the factors? We just start from 1 times 16. All right, this is the first pair of the factors. Then we go to 2 times 8. Then is it possible to go to 3 times something? No way. Then we go to 4 times 4. Right? So that's how we find out all the factors of 16. Includes 1, and then 16, and then 2, and then 8, and then 4. Right? Can I also count this 4 again? Not possible, right? It is not possible. You cannot count them twice. So there's only 1 4 is enough. Then you add them up since we are looking at the sum. So we can use the tips and tricks, which is 20 and then 10, and add them up, which is 31. That's how we go to the answer 31. Not just for this one, but also for this one. It's about, how comes it is 21? Seriously? Am I right? You add them up. This part is 10. This part is 20. You add them up. It's supposed to be 31. Good deal. Now let's just go back for this one. It's about somebody's present age is a factor of 72. Now 7 years ago, his age was a multiple of 5. Now find the sum of the possible present age of him. Oh, how can we find out? First thing first, let's just find out his present age. What can it be? So just find out all the factors of 72, right? So for 72, start from 1. It can be 1 times 72, right? Can it be 2 times something? It can be 2 times 36. It can be also 3 times 24. All right, 3 times 24. Yes, that's 72. What about 4? It can also be 4 times 18. Right? Any others? Great. Any others? Answer the question first, idea. Any others? Any other possible? Still got. Then we go to 5. Is it possible to go to 5? No. 6. That's 6 times 12. What about the next one? 7? No. 8. That's 8 times 9. So then you will find out that for the present age, for the current age, since it is a factor of 72, you got quite a lot. Then one very important word says 7 years ago, his age was a multiples of 5. Is it possible now he's 1? Well, now he is 1. Then 7 years ago, what is he? We don't even know, right? So which means the number, the factor which is smaller than 7 is not possible. Not possible for 1, not possible for 2 and 3 and 4 and 6. They are all not possible. Then we can just start from 8. All right. If it is 8 this year, so 7 years ago is supposed to be 1. Is it a multiple of 5? No. What about this year? When he is 9, is it possible that 7 years ago he is a multiples of 5? No. Continue. What about 12? When it was 12, or when he is 12, so 7 years ago is a 5. Is it possible? Yes. So the first possible age is 12. Continue. What about 18? 7 years ago is 11. Is it a multiple of 5? No. What about 24? 7 years ago is 17. Is it a multiple of 5? No. Continue. What about 36? 7 years ago is 29. Still no. What about 72, the last one? 7 years later is before, 7 years ago, that is 65. Is it a multiple of 5? It is. That means there will be 2 possible age, which 7 years ago is a multiples of 5. Then don't forget, we need to find out the sum. That means we need to add them up. When you add them up, it's supposed to be 72 plus 12. That gives you 84. That's how we go to the answer, 84. This is one very, very tricky question, since it refers you to find out the factors of 72, which you got a lot, and also at the same time, you need to know how to get to the multiples of 5. Thank you so much. And let's continue. After the number theory, we also talk about geometry by teacher Apple. So by teacher Apple, we talk about the perimeter and area, and especially when for the challenge, we combine the two. All right. For this one, we are looking for the perimeter. Do you remember when for the perimeter, all right, for the irregular shape, do you still remember how do we do? We should use the push out method, right? So let's try the push out. How do we push out? For this line, we should just push it out here, right? Let me just draw out for you. For this line, we just push out here, like ching, and push it out here. Then for this line, we can also just push it out here. right? And then for this one, we push it out. Then you will find out that actually for the line, after we push it out, that would be the perimeter of this rectangle. So for the perimeter of the rectangle, it's actually 2 times the length plus the width, which is 10 plus 8. That gives you 2 times 18, which is 36 centimeter. Is that the end? Is that the perimeter for the whole shape now? No way, bro. No way. Why not? It is because look at this one. When you push this out, push this out, push this out, is it complete now? You still have 2 more lines, which is stay there, here and here, which is 3 centimeters. So you still need to add them in, which is 3 at the left and then 3 more at the right, which is 6 more. That is 42 centimeters. That's how you come to the answer, 42. So for the irregular shape, you can just push it out to find out. But don't forget, once you push out, you need to notice that some of those you didn't push, just like these 2 lines inside. Don't forget about that. All right? And also, we have one more. It's like this one. This one is quite tricky. It says the figure below is made up of 3 identical rectangles like this, each with an area of 24 centimeters square. Find the perimeter of the figure. For this one, actually, we can just find out the line first, right? Since you can see this line, this one and this one can just add up to a 6, which means the width of one small rectangle is 3. If you already know that the area of the rectangle is 24 cm square, can you just let me know the length of one rectangle? Which is 24 divided by 3. That equals to 8 centimeters. That means this part is 8, this part is 8, this part is also 8. Then you might say, Mew, I don't even know about this. I don't even know about this. But do you know for this part, add up with this part is supposed to be what? 8 lor. Yeah. So with these 2 lines, let me just show you. This line with this line add up is supposed to be 2 such lengths. Take away 1/8, which would remain as 1/8. Then you say, Mew, I don't understand. It's okay. Let me just show you again in another easier way. You see, for the whole length here, I use another color, which is the purple one, all right? For the whole length here, it's supposed to be what? It's supposed to be 16, right? Because you got 2 lengths here. For this 16, you need to take out the blue color one, which is actually the part that you don't want. It's not the perimeter, right? Which is 8. So that is 16. Take away 8 to get the rest of these 2 parts is supposed to be 8. Okay. Now that you know this 2 part is 8. Also, don't forget this one at the left is 3. So you can just add them up, which is 1, 3, 2, 3, 3 threes, 4 threes. 4 times 3 plus 1, 8, 2, 8, 3, 8, and don't forget these 2 parts, 4, 8, so 4 times 8. You would get to 12 plus 32, and the answer is 44 cm. Good idea. Some of you just let me know that we can try the push-out method. Also can is can. As long as you can find out the method that you feel okay with, that you can just try. Very good idea. Thank you, everybody. And this is so much for all the module that we have. And this is the calendar that we have for phase 1. For phase 1 of the preparation of GEP, right? Now that we finished, what we finished is about 2 online webinar. And then the mock test one, which is on the 29th of April. Then for the intensive training, that which is about our modular boot camps, that which we end on today, the 24th of May, which is tomorrow. All right, we end today. And then for the events that we are coming, which is the mock test 2, which is an online mock test on the 27th of May. And then this one we will just move up one day forward, that is 6th of June, which is an in-person mock test. All right. And then coming up, we are having the collection and also the online short-term course. Let me just show you the way to get enrolled. So for this one, for the mock test, which we have 2 mock tests coming up, that is on the mock test 2, which is an online one, which is next Tuesday. You can just scan the QR code to sign up for both mock tests. For the online one, which is next Tuesday in the afternoon. And the in-person one, which is the June the 6th, which is a Friday. We have 2 different time slots. One is 9:30 to 12. One is 2 p.m. to 4:30. You will find out that the time is a little bit longer than the exam itself. It is because after the mock test, there would be an immediate analysis as an in-person class. So if you want to join the mock test, please get the QR code, and later I will also send this page in the group. All right. After the mock test, we also have the short-term course, which is an online short-term course about the GEP Maths 2000 essential questions, which would happen at 17th to 20th of June, every day from 10 to 12. All right, it's conducted by teacher Apple and Mew. So you can just sign up here. And then again, for all these events that I just mentioned, they are all free for the current students. So there is already a voucher there bound in your account for the current students. You can just direct sign up free. For the rest of the students, you can just join. And thank you so much. Later on, we still have the following events including the online mock test, in-person mock test, and the exclusives, the preparation, collection, and also for the short-term course. Thank you so much for the boot camps. And for those I need to mention about that is about our coins, right? Most of you just submit your daily challenge and extra bonus on time. Well done, everybody. That's a very good job to you. So for the submission, which we would just give coins on next Tuesday. That means before next Tuesday, you still can submit to earn coins. But after next Tuesday, any submission won't count it for coins. All right. So everybody, if you still need the coins, you still can submit. But then by Tuesday. All right. Thank you so much. And see you guys in the mock test and the in-person mock test. I know some of you never see me in person, right? That's when you can see me in person. All right. See you guys and bye-bye.